All right, today we're going to unlock one of the most famous, and I mean genuinely useful formulas in all of mathematics. It's this piece of ancient wisdom that's literally built into the fabric of our modern world.
So, what do all these things have in common? It's a good question, right? Because at first glance, you'd think not much. But the truth is, they can all be understood with a simple, really elegant equation that was discovered thousands of years ago. And there it is. A squared plus b squared equals c squared. This, right here, is the Pythagorean Theorem. And I promise, by the end of this, you are going to understand exactly what it means and how to use it like a pro. Okay, let's dive in. Okay, so first things first, before we can even touch the formula, we need to understand the playing field. I mean, what kind of triangle are we even talking about? Because it turns out this theorem is pretty picky. It only works for one very special type. And this is the most important part, so listen up. This formula only works for right triangles. You know the ones I'm talking about. They've got that perfect 90-degree corner, just like the corner of a square or a book. If you don't have that right angle, well, the magic just isn't going to happen. So those two sides that come together to make that perfect corner, we call those the legs. In the formula, we just label them A and B. And honestly, it doesn't matter which is which. You can swap them, it's totally fine, as long as they're the two that are making that right angle. And then there's that third side, the one that's kind of stretched out across from the right angle. That one has a cool name, the hypotenuse. We always call it C. And here's a key thing to remember. It is always the longest side of the triangle. No exceptions.
So, okay, we've got our parts, right? Legs A and B, and the hypotenuse, C. Now for the fun part, how do we actually use this thing? Let's get into the nitty-gritty of how the formula helps us find a missing side.
Let's kick things off with the most common situation you're going to run into. Imagine you know the length of the two shorter sides, our legs, A and B, but you have no idea how long that big one, the hypotenuse, C, is. How do you figure it out?
You know, the process is actually super straightforward. Step 1, take the length of leg A and square it. Multiply it by itself. Step 2, do the exact same thing for leg B. Step 3, add those two new numbers together. And for the final step, just find the square root of that total. And bam, that's C. That's your hypotenuse.
For example, let's take the most famous right triangle of all time, the 3, 4, 5 triangle. So if leg A is 3 and leg B is 4, you square them to get 9 and 16. Add those up, you get 25. And what's the square root of 25? It's 5. See? 3, 4, 5. It works out perfectly.
Now, what's really cool about this formula is how flexible it is. To find the big side, C, you add the squares. But what if you already know the hypotenuse and you're missing one of the shorter legs? Well, it's easy. You just flip the operation. You subtract the square of the leg you know from the square of the hypotenuse.
So let's try an example with subtraction. Let's say we've got a hypotenuse of 10 and one leg that's 6. Okay, so we do 10 squared minus 6 squared. That's 100 minus 36, which gives us 64, and the square root of 64 is 8. The missing leg has to be 8 meters long.
Okay, enough with the numbers on their own. The theory is cool and all, but where does this stuff actually show up? Let's see how this powerful little formula gets put to work in the real world.
Okay, here's a classic problem. Picture this. You've got a 5-meter ladder leaning against a wall. The bottom of the ladder is 3 meters away from the wall. So the question is, how high up the wall does the ladder actually reach? Think about it. The ladder itself is the hypotenuse. The ground is one leg. What's the other leg?
Did you get 4 meters? If you did, you're exactly right. The ladder, the wall, and the ground make a right triangle. We know the hypotenuse is 5, so we subtract. 5 squared minus 3 squared, that's 25 minus 9, which is 16. And the square root of 16 is 4. You just solve for the missing leg.
Alrighty, here's another one. Think about any rectangle around you, maybe your phone screen or a TV. When you draw a diagonal line from one corner to the other, what do you get? You get two identical right triangles. So if a screen is 12 centimeters by 9 centimeters, how long is that diagonal? The answer is 15 centimeters. In this case, the diagonal is the hypotenuse, so the sides of the rectangle are the legs. We just do 9 squared plus 12 squared, which is 81 plus 144. That adds up to 225, and the square root of 225 is 15. Simple as that. So you see, this isn't just some formula you memorize for a math test. It's way, way bigger than that. It's a fundamental principle, a cornerstone of science that helps us describe the world around us. I mean, think about it. It lets you check if a corner is a perfect 90-degree angle. It's absolutely essential in geometry, trigonometry, physics, engineering, you name it. It's used everywhere from construction to navigation. And here's a really cool bit of history. We call it the Pythagorean Theorem, but it was also discovered independently in other places, like East Asia, where it was called the Gogu theorem. It's just a fundamental truth.
And this right here, this is a cheat sheet of some of the most common right triangle values where all three sides are perfect whole numbers. These are called Pythagorean triples, and they are incredible shortcuts. You'll see the 3, 4, 5, the 5, 12, 13. Builders and designers use these all the time to get a perfect right angle without any complicated math.
So there you have it, the Pythagorean Theorem. A beautifully simple formula that helps us understand the world around us. Now that you know the secret of a squared plus b squared equals c squared, where are you going to find right triangles hiding in plain sight?